Okay, let's have a look. The next problem we want to discuss is the arbitrage opportunity. So what's the meaning of arbitrage opportunity? An opportunity to earn and expect positive net profit and with no net investment of money. So in other words, you don't invest, you don't use any money to invest, but you will earn a positive return. So that's the arbitrage opportunity. In Chinese, we also call 空手套白狼. And the second is APT assume there are no market imperfection preventing investor from exploring arbitrage opportunity. So the last is if you find that arbitrage opportunity, you can use extreme long and short position to earn that opportunity return. And this extreme long short position means that the investor find that opportunity, they can buy or sell enough stocks. So in the market, you can find enough stocks for that. And you will, finally, the mispricing will disappear immediately. So maybe a second, this mispricing will disappear. So that's the arbitrage opportunity. So let's have a look at an example for this arbitrage opportunity. So I suppose that there is an investment firm use a single factor model to evaluate assets. So here you can consider there are 3 different portfolio A, B, C, and the expected return we give it to you. And the last column is our factor sensitivity. The problem I want you to solve is the first using the portfolio A and B to calculate the zero systematic risk assets return and factor risk premium, which is lambda 0 and lambda 1. And the second problem I want you to show me, is there any arbitrage opportunity and how can you to explore that arbitrage opportunity? Okay, let's have a look. Based on A and B portfolio, we can have the lambda 0 if you have looked at portfolio A, and we have the beta, which is BI, and multiply the lambda 1. Which should equal to your expected return. So that's your APT model. So it should be equal to 7%. So that's for portfolio A. And the same method, you can do that for portfolio B, which is 7.8%. Should equal to lambda 0 plus 1.2 multiply lambda 1. And we write down the 2 portfolios APT model, and there are 2 parameters, lambda 0 and lambda 1. You can solve both of them to find lambda 0 equal to 3% and lambda 1 equal to 4%. Okay? If you saw this result, definitely you can write down your APT model. It should equal to ERI should equal to 3% plus 4% multiply BI. So that's your APT model. And after you solve this lambda 1 and lambda 0, the next question I want you to find, is there any arbitrage opportunity? Let's have a look. Is there any arbitrage opportunity? So we know the portfolio A and B, the sensitivity, factor sensitivity is 1 and 1.2. So if you invest 50% in portfolio A and 50% in portfolio B, definitely the factor sensitivity should be equal to 1.1. So this 1.1 is exactly the same as the portfolio C. Now let's have a look at the expected return. What happened for expected return? We know that we invest half to portfolio A and half to portfolio B, so the expected return should equal to 7.4%. Now let's compare the 7.4% with 7.5%. So half of portfolio A and half of portfolio B will give you lower expected return compared with the portfolio C. In this case, we will sell half of portfolio A, half of portfolio B, and then buy all to portfolio C. We will earn the arbitrage opportunity, which is 0.1%. So that's the case for arbitrage opportunity. Now let's have a look at the second example. Ask you to calculate expected return from the arbitrage pricing model. An investment firm, the same employee, now we employ two-factor APT model. The rate of return on a zero systematic risk assets lambda 0 is equal to 5%. And determine the expected return for the investor fund using the following data. So let's have a look. The following data I give you, the factor 1 and factor 2, the factor betas, and also the factor risk premium. So how can we calculate the expected return for this APT model? So we know the expected return should equal to your lambda 0, so you can write down 5%, and then you plus lambda 1 multiply B1, so the lambda 1 should equal to, we have this here is 0.03 multiply 1.5. So that's the lambda 1 multiply B1, and then we have two factors, so the next one we need to plus lambda 2 multiply B2, so that's the 0.0125 multiply 2. And then we will get the final result is 12% for our expected return. So that's the APT model. How can we solve this problem? Now let's have a look at the example 3. For example 3, we suppose that there are two factors explain the return. And according to the APT model, an arbitrage opportunity exists unless the APT hold. So determine the parameter in APT model using the following data. So we want to use the following data to solve this APT model. So we have three different portfolios, and we also have two different factors. So we solve that. APT is quite simple. You just use the expected return for portfolio A. So let's solve the portfolio A is 0.14, should equal to our lambda 0. So we don't know the lambda 0. We write down lambda 0 plus lambda 1 multiply B1. So B1 is 1 here, and multiply lambda 1, and plus B2 is 1.5, so 1.5 multiply lambda 2. And then you can write down the same similar one for each portfolio. So portfolio B, you have 0.12 equal to lambda 0 plus 0.5 multiply lambda 1 plus 1 multiply lambda 2. And for the portfolio C, you have 0.11 equal to lambda 0 plus 1.3 lambda 1 plus 1.1 lambda 2. So you have three equations. So you have three equations and also three parameters. You solve this one, you get the final result. So we solve this equation and get the result here. So that's our final APT model. Okay, in this 6.1, we introduced the arbitrage pricing theory, which about the assumption for APT and compare the difference between CAPM and APT. And finally, we introduced the arbitrage opportunity and how can we solve the APT model and find the arbitrage opportunity. Thank you.